All right. One of the last ones that you guys identified as a particular challenge was when it comes to graphing. And graphing has not changed since the very first unit. Now, a lot of people say, oh, that's hogwash. Of course it has. It really hasn't. The techniques have stayed the same. Now, the equations and what gets graphed, that might change, but these techniques stay the same, so I would like to just go through the techniques one more time. If I have a general graph, I'm going to call it A versus B. Nice and easy. We don't have any idea what these variables are. A versus B. And there happens to be a relationship between them. I can recognize that this line would be a proportional relationship or a linear relationship. But there's a number of different things that I would be able to do with this graph. The first thing that I can do is I could read it. Now what this means is that given A, what is B, or given B, what is A. So taking a look at this, an example would be how much is A if B is 7 whatever units it has. Well, this is easy. I would just then, given B, go up to this line to see what value A would be. This is the most straightforward, and we don't really deal a whole lot with this in physics because it's the expectation that you guys have this skill, that if they ask for a certain value on the x-axis, you'd be able to give us y, or if they ask for a certain value on the y-axis, you'd be able to give us x. So some value up here, you could read over and see what the x would be. What we really focus on in this class is number 2 and number 3. Number 2 is the slope. Now, whenever I end up finding the slope, I end up with the y-axis divided by the x-axis, just like it is in mathematics. Now, whatever the y-axis happens to be, then that variable goes in there, but we always end up with some kind of a meaning from the slope. Depending on the variables, there could be meaning here or there could be not, so you have to establish, are the units something I recognize and does that have a meaning? And we'll look at a particular example a little bit later on. But finding that slope, I would just go ahead and take the y-axis divided by the x. The third thing that we could do is actually find the area. Now, generally, what that means is that I would take the y-axis and multiply it by the x-axis. And, of course, there is extra meaning here. The real key is when I do this function, what are the units? When I do this function, what are the units? This is going to tell me what is the meaning of what I just did. Let's take a look at two examples, an example of slope and an example of area. Also, I'll give you an example of what it is to read the graph. Here is a very common example that we would see in class. It's a force versus charge. And one thing that we discovered is that charge and force are directly proportional. So the graph would look like this. The first technique that we could do reading the graph would be something as straightforward as, with 6 coulombs of charge, how much force was acting on it? So you would go to the 6 coulombs of charge, you would go up to the line to see where it crossed, and then you would go over here and it looks like 80 newtons of force. Okay, so if I had 6 coulombs of charge and 80 newtons of force, that's what I ended up with. That's about as straightforward as it gets. The second thing though, slope. I want to be able to find out if there's any meaning when I take the slope, so I would have to take a look at the units. The units of charge are in coulombs, the units of force are in newtons, and so if I find the slope, I'm going to be taking the y-axis and dividing it by the x-axis. In this case, that means I'm going to be taking force and dividing it by charge. And when I go ahead and find force and divide it by charge, I end up getting, as we know, the electric field. I end up getting newtons per coulomb, which I know is the electric field's units. That's how I was able to establish that by taking the slope I would get the electric field, as I looked right here at the units, and a newton per coulomb is electric field. So if I were to take this slope, I would be able to say, pick 2 points on the line, and I'd say, okay, I got 30 and 2 and 80 and 6, so I would have the change in y over the change in x. So the change in y would be 50 newtons. The change in x would be 4 coulombs. And I could go ahead and divide this through and figure out exactly how much my electric field is. And it turns out to be 12.5 newtons per coulomb. That's the electric field. The last technique that we use is the area, number 3. And just as the other techniques that we had, we end up having to look at the units in order to see if there's any meaning there. Now, we have never seen this graph before. We have E field versus distance. Okay, so never seen that before. Well, what if I told you that the E field that we had and the distance, nice steady E field, and we have this nice little displacement here, and if I wanted to find the area and see, is there any meaning here, I would have to take y times x. Now, a nice little cheat way to take a look is go ahead and look at your equation sheets and see if anything is E times D. But another thing we could do is we can say newtons per coulomb, that's the units of an E field, times the units of distance would be meters. So I'd end up with newton meter per coulomb. And as we all know, a newton meter, another name for that would be a joule. So a joule per coulomb. And I would have to ask myself, is a joule per coulomb anything that I've noticed before? And sure as enough, that is voltage. So I can tell that if I find the area under this graph, I'm going to get the voltage. So I might ask a question, and let's say this is at 6 newtons per coulomb, and I might ask the question, over the displacement of 10 meters, what is the overall voltage? And so I can see, well, I'm interested in this 10 meter point, and I would have to find the area between the line and the x-axis. And I could see that I end up with 6 times 10, so that's 60 joules per coulomb, and say, well, there you go. I got 60 volts if I happen to have an E field at that distance of 10 meters.